Hey guys, Richard Holdner here. We're going to take a look at the giant Ford small block cylinder head test part 2. We're taking a look at heads from Airflow Research, Brodex, Canfield, Edelbrock, Roush, Ford Racing, TrickFlow, and World Products. Lots of cool stuff. So let's start off by taking a look at all the specs on the heads, and hopefully I configured them so they're easier to read this time. Then follow that up with all the power gains. Let's jump in.
Okay guys, you can see we've organized all of the specs on every cylinder head that we tested in Group 2, starting with the stock one, the World Products Aluminum Light Windsor Jr. head, GT40X, TrickFlow Twisted Wedge head, the standard Twisted Wedge head, the Edelbrock Performer RPM, a Roush 200, Canfield 192, and Airflow Research 185, the Brodex ST50R, and the Ford Racing Z304 head. We have all the specs. We've got chamber size, intake and exhaust port volume, intake and exhaust valve size, the installed height for the springs, the seat pressure, the open pressure for the springs, where they coil bind. You can see they all have more than enough for the camshaft that we ran for the Extreme Energy 274 cam, and also the valve train weight. This should be a little easier to read than the specs in Group 2. Maybe I'll go, or the specs in Group 1, maybe I'll go back and redo that so you guys can take a look at that. But all the information is here. You guys can kind of compare this and correlate. Here's something to note on the Canfield head. The combustion chamber obviously was a lot smaller than the others, but they varied from that low, that small at 53 cc's all the way up to 64 cc's. So 10 cc's would change the combustion chamber, or the combustion chamber's change would change the compression ratio by, at least a full point. So that's something to think about. Also, take a look at the port volume and maybe compare that to the airflow numbers. Take a look at the exhaust flow also, and then compare that to the exhaust port volume. Most of these had 202 intakes, although obviously the stock one was much smaller than that, but the GT40X had a 194. Again, most of these had 1.6 exhaust valves, the GT40X, the 154, and then the stock head obviously was the smallest of the valves. You can take a look at the other specs. Lots of good stuff here, but let's get to the airflow data. Okay guys, this data should be a little easier to read than the Group 1 stuff. As you can see, we've got all of our different cylinder heads: stock, World Product, Windsor Jr. Light, the GT40X, TrickFlow, Edelbrock, Roush, Canfield, Airflow, Brodex, and FR500, or the Ford Racing Z304, not an FR500. And we've got flow lifts ranging from 50,000s all the way up to 650,000. So you can see where these heads kind of sign off at, and what kind of flow that they have at each one. You guys can compare the flow. This is on the intake side. We also have exhaust flow. This is the intake flow. Now you can compare this, at each different lift and kind of see where some of these shine. And then if you correlate that with their port volume, you can get even more information and figure out how efficient they are. And if you guys get all fancy, you can take some of this data and calculate the coefficient of discharge by multiplying these numbers and using it with the intake valve size. And then on the exhaust size, you use it with the exhaust valve. You use the exhaust valve size and find out how efficient they are, how well they did what they're supposed to do. I like to also correlate it versus port volume, because then you can see, if we have a big port, we expect it to flow well. If we have a smaller port and it still flows the same number, I think that port is more efficient. So let me know what you guys think in the comment. But here is all the flow data. So you guys might want to look through here and see which one flows the most. Although it's important to note, if you look out here at like 650 lift, even if something flows more, one flows more than the other, the reality is our camshaft only had between 550 and 600 lift. So those numbers are probably a lot more important. And as always, on every cylinder head, on any kind of engine combination, take a look real specifically at the mid-lift flow stuff, because that's kind of where I think that's what determines power output, is the mid-lift flow. So take a look at that stuff. Lots of good data here. Let's take a look at the exhaust. So before we get to the power numbers, here are the exhaust flow numbers for all of the cylinder heads. Again, we've tested them from 50,000s lift all the way up to 650,000 lift. And I did that so that you guys, you might be running a lot more camshaft than that. Obviously, if you're running a 333 stroker like we did, or a 347, you might want to run more camshaft in it. I mean, the Extreme Energy 274 cam's a real good cam. I like it for 5-liter stuff. Honestly, I think in retrospect, this probably was a little bit small for what we were doing, and to really show what these heads could do, because some of these flow, on the intake side might have flowed 270, 280, so that's enough to support, 550 horsepower. So maybe one of the XFI cams or something could have been a better choice, but that's what we did back in the day. Here are all the flow numbers. Again, pay close attention to the mid-lift flow numbers and also take a look at the exhaust flow numbers and kind of correlate those with the power output that you're going to see when you take a look at all of the horsepower data. So which ones had good exhaust flow? Did that correlate with the combinations that made the most power? Did combinations that had good exhaust flow and good mid-lift flow, did those make power? Did take a look at the port volume and kind of compare that to the exhaust flow data and see how they're doing. Obviously, valve sizes, most of these, again, had 1.6 exhaust valves. That's kind of a standard thing. Everybody picked the small block Chevy valve size of 202 and a 1.6. Here is the exhaust flow data. So now, let's get to the power.
Because we knew the heads in this group were going to flow more than the ones in Group 1, we wanted to have a test motor that could take advantage of that extra airflow. So we built a motor that was larger than the 306 that we ran in the first group. We built a 333-inch stroker, and that was a combination of a 4040 bore on a 5-liter production hydraulic roller block. We combined that with a 3.25-inch stroke. It had forged rods and forged pistons, and the pistons on these were effective because they allowed us to run both inline valve heads and the twisted wedge head, so they required different valve reliefs. So we had dual valve reliefs in these pistons. We also had a bigger camshaft. We stepped up to my favorite cam, the Extreme Energy 274 HR cam, and that worked well with these heads. Although these heads, like they did in the first part in the first group, these will all support a lot more power, as you can see by the flow numbers. If you guys take a look at that data, they'll support a lot more power. But you can see the difference here. We ran it with a dual plane intake. In this case, we didn't run an Edelbrock RPM air gap. We ran a Speedmaster dual plane. We ran a 750 Speed Demon carburetor and the same 1 3/4 hooker long tube headers on this thing. This thing had a girdle, and although probably wasn't really necessary, all of the heads were run with 1.6 ratio roller rockers. Now, there were different rockers with different heads because they required different heads. Some of them required bolt-down rockers. Some of them needed to have bigger studs in them. So but we made sure that they were all aluminum and that they were all 1.6 and they were all from Cam. So all of that worked out really well. Equipped with this setup, all of the compression ratio on these heads they were all over 10 to 1. You can take a look at the difference in the combustion chambers. We ran the heads as they were supplied, so I wasn't trying to even out the compression ratio on any of this stuff. I just wanted to show what the head did as the guy, the way that a particular guy would buy them. One of the heads, the Canfield heads, had very small chambers. It had 53 cc chambers, so that raised the compression ratio up over 11. And as we'll see, obviously it had a positive effect on the power output. The other thing that we had to do is go through all these different heads. A lot of these different heads require different pushrod lengths. The pushrod lengths on this test varied from 6.25 inches all the way up to 6.7 inches. So again, we had to make sure that the heads were run with the right pushrod length. It's very important. Now, what we did was start off, as we always have. In fact, we started off with the exact same cylinder heads that we ran, the stock heads, in our first group, and run on our 333-inch motor. These stock heads produced 352 horsepower. So they actually did very well, especially given the fact that they only flowed 166 CFM, and they produced 400 foot-pounds of torque. So a lot of guys might be wondering, how are you making that much power with a set of stock heads? Well, the reality is that they flow more than that when you flow them at more than 28 inches, which is essentially what we did by putting a stroker on them. Now wait till you see what happens when we ran these same heads on a 392-inch stroker, which would put even more draw on the heads, which increases the flow rate. It allows you to make a little bit more power, but obviously there's a limit to where you can get to. Now our first set of heads that we ran, comparing to the stock ones, were a set of World Products light heads, basically aluminum version of their of the World Product Windsor light. They call them World Product Windsor light heads, and as you can see, they did pick up power. The peak power jumped up to 386 horsepower. Peak torque was up as well to 419 foot-pounds. You can see they added power basically everywhere. So this was a nice little upgrade compared to the factory heads on this 333. Our next set of heads came from the guys at Ford Racing, out of their Ford Racing catalog. They were GT40X heads, and obviously a step up from the standard GT40 aluminum head. That was kind of their, super racy GT40 head version. And they did fairly well. They produced 391 horsepower and 417 foot-pounds of torque. You say they offered power gains through most of the curve, except down here at the very bottom from 2,500 to 2,900 RPM. And they picked up, 40 horsepower or so. So it was a good gain, and they were obviously ready, available for racing. Sold a ton of these, so they worked out pretty well. Let's take a look at our next set of heads. Our next set of heads came from the guys at TrickFlow, and although they didn't make the most peak power, you can take a look and see. This was their twisted wedge head, and the reason why we had to have a dual valve relief in our pistons. Equipped with the twisted wedge heads, they produce 438 horsepower. And this is an as-cast twisted wedge. This is long before they did any of their CNC stuff or even their fastest cast stuff. And 436 foot-pounds of torque. Gains everywhere from 2,800 to maybe a slight loss down below, although that may just be a function of the way that we loaded it. These twisted wedge heads did very well, and that's why they sold a ton of these things. I mean, everybody had the twisted wedge because in addition to making good power, they also improve piston-to-valve clearance, allow you to run a little bit bigger camshaft. The thing that they did win, although they didn't make the most peak power, they did win in the amount of power that they made compared to the cost. So in a amount of horsepower gain for the expenditure, the TrickFlow twisted wedge head was obviously the winner in that group. Let's take a look at our next set of heads. The next head run on our 333-inch stroker came from Edelbrock, and Edelbrock does something interesting. They kind of do a three-tiered approach to their cylinder heads. So we tested the normal Performer heads before, and these are the Performer RPM, and then obviously the next one are their Victor Jr. And they do the same kind of thing with their intake manifolds, and it's an interesting approach, and it's pretty effective. Run with these Edelbrock RPM heads. Our combination produced 431 horsepower and 428 foot-pounds of torque. Again, like the twisted wedge heads, they improved the power output through the whole curve, except for a little bit of a change down here at the bottom. Ran out past 6,000 RPM, and over 431 horsepower. So that's good. Those are good power gains compared to the factory head. I mean, you're looking at about 80 horsepower there. So it's a nice gain from a cylinder head upgrade. Let's check out our next set. Next up on our 333 was a set of iron cylinder heads from the guys at Roush, although I'm pretty sure somebody else did them for them, either Dart or World Products. They had 200cc intake ports, iron heads, non-CNC ported. And as you can see, they made 391 horsepower. So they're kind of down on power compared to some of the other ones in this group. They produced 411 foot-pounds of torque. Maybe dropped a little bit down here at the bottom. Mostly gains. Kind of comparable, I would say, in power to, the other Ford racing offerings, the GT40 stuff, or maybe the Windsor Light stuff. But again, had the famous name on it, so a lot of guys bought them just because of the Roush name. This next test is kind of cool because it demonstrates both a problem and how we cure this. And this is something that was common during the cylinder head test. So I mentioned that a bunch in our first video where we talk about the valve springs on all of these things. And it seems like nobody wanted to supply enough valve spring in their head the way that they supplied them, right from the manufacturer. But our next test was a set of Canfield heads, and these were 192 Canfield, so they're bigger than the 170s that we did in the first part. But if we take a look at the Canfields, they were on their way to making really good power, and this big drop off here was valve spring. They just went into valve float, and I'll show you what happens. This is kind of cool. What it looks like when you cure valve float. What we did was put a different inner spring on it because that's what we happen to have at Westech to kind of cure this problem. So we increased the spring rate by about 30 or 40 pounds of seat pressure, if I remember right. And here's what happened when we cured the valve spring problem. You can see it wants to carry the power out farther. Now, it didn't make a ton more power in the area before we had valve float, but it did allow the thing to carry out and eventually make more peak power. So once we cured the valve spring issue, these made 442 horsepower and 447 foot-pounds of torque. They offered power gains basically through the whole curve. And as I mentioned previously, these heads had the smallest combustion chamber, so they had the highest static compression ratio. It was over 11-to-1, so good on them for supplying a set of possibly tricked up heads. These seemed like they had a little bit of blending in the bowls as well. But they are a good head. We ran these Canfields and other Canfields a lot, and they work well, especially back in the day. This was a good head, and again, it shows you what happens when you don't have enough valve spring pressure. Much like the guys from Edelbrock, the guys from Airflow Research had a 3-tiered approach on their cylinder heads for the small block Fords. Actually, they had a one step up above this, but their big sellers were their 165, the 185, and the 205 heads. They also had a 225, I think. This test was run on their 185 heads. We ran their 165 heads back on the smaller stuff with a 306. Here's what happened when we installed the 185 heads on our little stroker. They produce good power, 448 horsepower. As you can see, they revved out nicely past 6,000, all the way past 6,000 RPM. Peak torque was up to 445 foot-pounds of torque. They improved power everywhere through the entire curve. Good torque gains, good power gains. This is kind of what we have come to expect from the guys from Airflow Research, or certainly did back then. All of their stuff seemed to perform fairly well, and they have... if you take a look at the flow numbers, they have good mid-lift flow numbers, which kind of helps produce power. And they also seem to have very good exhaust flow numbers, which again, I think should also help. And it might be possible, and let me know what you guys think in the comments, does an Airflow Research head, because of this, and especially because of the exhaust flow, does it need different cam timing than these other heads might? So something to think about. Back in part 1 on the smaller 306, we tested a set of heads from Brodex, the ST 5.0 heads, and these are the R version, so obviously bigger ports, more flow. Here's what happened when we installed these Brodex heads on our 333. Good power gains, as we've come to expect from the guys from Brodex. Obviously, they know how to make power. They know how heads work. 434 horsepower. Torque was up to 437 foot-pounds. Gained throughout the entire RPM range. Didn't lose anything, even down at 2,500 compared to the factory head. So if you put these heads on your 5-liter, or in this case, a stroked version of your 5-liter, obviously they're going to work very well. And given the flow rates of these heads, they can support a lot more power than we're making here. So easily a good upgrade for any 5-liter combination. Our final set of heads in this test came from the guys at Ford Racing. These were kind of their big boy heads at the time. They were new when we did this test. They were the Z304 heads, and I think that somebody did these for Ford, maybe Canfield or somebody. But here's what happened when we put the Z304 heads on. They picked up a lot of power, did very well, produced 436 horsepower. And 439 foot-pounds of torque, and like the other heads in this group, they picked up power basically everywhere. So again, kind of what you're looking for from a cylinder head upgrade. And they didn't really lose much power down low, even though they had fairly big port volumes. In fact, we considered putting these into the next group of heads because they were fairly big port volumes, but we ran them in this group and they did well as expected. Again, the big boys from Ford Racing. Let's get to our conclusion. Well, guys, that concludes part 2 of our giant cylinder head test. And the interesting thing is the takeaway from all of this is not usually what people want or or what they take away from it, because when we do a head test like this, they all see it as, okay, this is the big shootout to end all shootouts, and I'm going to find out finally what the best set of cylinder heads for my small block Ford is. And really, that's not the case. I mean, if you talk to old timer guys, they're going to tell you, oh, back in my day, we didn't have any heads for the small block Fords. We had the stock head, which you could port, or the go-to head was the 69 351 Windsor head, which you could then port, and that was really the super wazoo race head for a Windsor application, or you could obviously put Boss heads on it, which was also kind of a cool deal. But now, or at least when I did this test many, many years ago for Muscle Mustangs and Fast Fords, there was like 30 sets of heads, and now there are even more. And for me, that's really the takeaway for a test like this, is this part and part 1 and part 3 and part 4 that are coming up. There's lots of heads available for the 5-liter Ford. There are lots of heads that will do what you need them to do. If you put any of these heads on your 5-liter Ford or 302 or Stroker, 327, 333, 347, whatever it is, all of these heads will do what you want them to do, especially if you're looking for something like this, where we're not taking advantage of every last CFM that these heads have available. All of these heads, if you take a look at the flow rates, will all support a lot more power than we were making in this combination. So if you're looking to do something like this where you want to make 400, 425, 450 horsepower out of a little stroker like this, almost all of these heads will do that. Not to mention the many more heads that are available now. Lots of offshore stuff, lots of good CNC stuff, like this stuff from ProMax and other places. There are lots of good heads out there that will do what you want them to do, and they'll also do it for a fairly affordable price. So unless you're looking to extract every last horsepower out of it in a race application with a dry sup at high RPM and a roller cam and all that stuff, all of these heads will do what you want them to do. And really, that's the takeaway. There's lots of good stuff out there for a 5-liter head and lots of good stuff for you to choose from. And I mentioned that in the trick flow deal. If you look at just not the power output, but also the cost to achieve that power output, it becomes an interesting question. And again, lots of other options for that. I'm Richard Holder, guys. Make sure to like, share, subscribe, ring the bell. Parts 3 and 4 are coming up. Make sure to tune in. More head stuff, more testing. All of that is coming up.